So one thing I want to demonstrate is probably how you did formatted output in languages like Java or Python. Or if you were a straight C programmer, how you probably did it in straight C. And that's by using format specifiers, a formatting string. I'm going to make a new project, call it Lecture F. Grab my boilerplate. Okay, these are C++ header files. I'm going to include some good old-fashioned C header files. #include less than stdio.h and greater than #include less than stdlib.h. Okay, I'm going to get rid of that. So let's say we had some data. Double pi equals 3.14159 blah 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 blah. I just typed in a whole bunch of characters. Okay, that was excessive. I'm not going to type in that many. There we go. Actually, since we have used math defines, we can just set double pi equal to underscore, or wait, m underscore pi. And let's say that we had something else. Int I1 equals 3, comma, I2 equals 9999, comma, okay. And then that's probably enough to demonstrate our purpose here. So here's how you might have done it in the past with a formatted string. Printf, parentheses, quote, and yeah, in Python it would have just been print. Same in Java, system.out.printf, something like that. Printf, we want to say pi equals, but we only want to print it out to 4 decimal places or 3 decimal places. So percent dot 3, meaning 3 digits after the decimal place, L, and it's real important to note that that's an L and not a 1, F, backslash N. End quote, comma, caps, PI. Now printf, parentheses, quote, I1 equals percent %d, backslash n, d standing for integer. I wish it was percent %I for integer, but I didn't make the language up, comma, I1. Guys, if you just came in and if you're going to type this, take a real careful note that that's LF. Right here. That's LF. Right there. Okay. And then let's print out I2 the same way. Printf I2 equals percent %d, excuse me, I2 equals percent %d. All right, so the textbook's not going to show doing this. And I'm probably not going to do very many examples where I'm using printf rather than cout. But it does work because C++ is backwards compatible with the C programming language. And now I'm going to run it. The first thing I will see is that hopefully pi has been restricted to showing 3 places after the decimal point, if I don't have any syntax errors. Yep, 3.142, 3 places after the decimal point. And then I1 equals 3 and I2 equals 9999. Now, what if I wanted these to be spaced out a little bit better? Like, what if I'd had something after that %D? I don't know. Like the word years. And I2 equals %D space years. And I wanted them to line up like they were in a spreadsheet or something. I wanted those years, those words, years, to be right on top of each other in the output. But they're not. I would need to get this one spaced over to fit here. And the way I can do that is to say I want this to be exactly a certain number of digits wide, a certain number of spaces wide. And since our largest data is 4 digits wide, 1, 2, 3, 4, I think I'm going to put a 4 between the % and the D. %D, %4D, %4D. That means this placeholder is going to be filled out. It's going to be padded with spaces until it's 4 characters wide. So since I1 is equal to 3, it's going to add 3 spaces to it to pad it out. Since I2 is already 4, it's not going to pad it out at all. Sure. So there we go. You see what it did? It padded them out. If you wanted it left justified rather than right, you could get that to happen with a minus sign. Oh, that is how it's done in a lot of other languages. And I kind of think that maybe I ought to start making us do it that way more, just so that when you go to those other languages, you're familiar with the idea. But maybe you already did that in Python. Maybe you don't need to worry too much about it. I hope this kind of looks familiar from those languages, using %D to print out a floating point, or excuse me, an integer. Maybe it was %I in Python, I don't remember. And then %F, it's just that since C is a strange beast and we're using double, which are double wide variables, we have to put an L there to mean long. Just like if we declared these variables as longs, these I1s and I2s as longs, we'd have to make it %4LD to stand for long decimal. You don't have to remember all that because I don't think we're going to be using printf much unless you take the C programming course. So for you folks who just came in, this is what we've added. I can print it out if anybody needs a printout. I bet more people need it and are just not fessing up. We want the same thing to happen when we're using cout, but there is no equivalent. Don't type this because it won't work. There's no way to do this. Cout %4D followed by I1. That'd be great if it worked, but it doesn't. Let's run it and see what it does, and then I'm going to delete it. So, like I said, you don't need to type. Oh, that's not supposed to be LD. It was supposed to be a ENDL. My mistake. ENDL. Okay, so run it, and it printed out %4D followed by the value of I1. Not what we wanted. But there's a something we can put there that will say I want it to be 4 characters wide. But to get those to work, we have to add a new #include. They require not only IOStream to get the cout, but we need one called IOmanip, short for manipulator. #, I'll put it down at the bottom. # include less than IOmanip greater than, and I'm going to comment as real big so that people know that I just changed for those who are typing stuff in. As a matter of fact, if you're typing stuff in, go ahead and add that to your # includes right here and now. Of course, you don't have to add the exclamation marks. All right, I'm going to get rid of that comment as long as the folks who just came in realize that that's a L. I guess I better not get rid of it. Okay. You don't have to type it in. Now we need to use something there that sets the width. And it's SETW parentheses 4 in parentheses. Now when I run it, it will be padded out to 4. Not that we could see it, right? Because we don't have anything around it to let us know it was padded out to 4. But let's print out I2 the same way. So I'm just going to copy that line and paste it and make it I2. And maybe it'll be clear that it was padded out. Maybe not. We may have to add a little bit more to make sure we can see it. Yeah, you see that? We can tell it was padded out to fill 4 spaces. One thing to note is that we had to call setW twice. If I did one more, cout arrow, just the number 3 or 32 or something, arrow ENDL, that one's not going to be padded out. You have to call setW each time you want something to be padded. What in the world is that? One notification. Okay, great. Alrighty. So, if I wanted that one padded out as well, I would have to add an SETW right there as well. As soon as it prints out something, the SETW is cleared. Meaning that if I wanted to print out 3 different things with setW with a width of 4, I'd have to call setW 3 times. Let's just do that. Cout arrow, and I'm going to wind up doing some cutting and pasting here after a point probably. setW parentheses 4 in parentheses arrow, I don't know, some number, 87. And then take this part right here, just copy that and paste it 2 more times so that we're printing out 3 things total. And then lastly an ENDL. And then copy and paste that and change those 3 numbers to something else. Doesn't matter what 3 numbers. Alright, and we can see that they're spaced out. That's what you use setW for, usually, is to line your numbers up in columns so that they're easy to read. Right? If you had a whole page full of data, it's a lot easier to read if they have commas. Excuse me, if they're spaced out in columns. So since I went way back to 1970 with these printf commands, we're going to go back to 1970 with some scanf commands, which reads from the keyboard. Printf, parentheses, quote, we're doing it old school, enter a whole number, colon, space, end quote, in parentheses. Int n for whole number. And then int result equals scanf, parentheses, quote, %d, end quote, comma, ampersand, n, in parentheses, n semicolon. Now that almost looks like a lot of gobbledygook. And then cout arrow, in arrow, quote, space, quote, arrow, result, arrow, ENDL. Ooh, do I have an error? Okay, it's telling me that this function may be unset. Use scanf instead. Okay, I'll do that. I need to put an underscore s after the scanf. I'm not going to even get into right now why that's considered unsafe. That is going to be a longer explanation. But I need to change, in order to get that error to go away, scanf to say scanf underscore s, which is a safer version of it. Fewer memory corruption errors result. That's putting that there. All right, we're doing it old school. Enter a whole number. All right, 4, 5, 6, 7, 8. Okay, and notice that the number that it read, can I get this to work like that? Right, in is what the value was. Right, when I typed in 56764, it got stored into that variable. Ampersand in. And then what in the world is this result? This result tells me how many variables were read. Here we only read one value. We're going to do that once more, and then we're going to drop the subject. Printf parentheses quote, now enter 2 more whole numbers separated by a space. Backslash n. Or maybe not even, yeah, just a colon. Result equals scanf underscore s, the safe version of it, parentheses quote, %d space %d, end quote, comma, and why don't we just reuse I1 and I2? So ampersand I1, comma, ampersand I2, close parentheses, semicolon. Now we're going to print out all of our data. So cout, arrow, arrow, cout, less than, I1, less than, quote, heck, why not put a comma here this time? Quote, comma, space, end quote, arrow, arrow, I2, less than, quote, comma, space, end quote, less than, result, less than, ENDL. So enter a whole number, 98. Enter 2 whole numbers, 100 space 200. Okay, so you can see that this result variable right here is holding the number of parameters that we filled in. Here we only typed in 1 number, so we got a 1. Here we had 2 placeholders, so we got a 2. To use scanf, you use a formatting string, kind of like we did with our printfs, and then we pass in the address of the variable that we want filled in. Alrighty then. We're going to go back on our time machine and leave 1970 and come back to modern times, because now that we've learned CIN, right? You know, CIN like that, the syntax is a lot cleaner, a lot less prone to getting the memory corruption that scanf can cause. So, having had you type all that in, I probably will have you comment it out, just so that we don't have to keep entering those things every single time. But I'd kind of like for you to get it to run first before we comment it out. But I'm going to show you something different than commenting out code. Above that first printf, I'm going to do # define space old school all in caps. And then the next line is going to say # if def old school, and then down here at the bottom but above my system pause, I'm getting an error there. Oh, because I was just about to type this. # indif. So we have ifdef here, ifdef old school, and then indif. Now what this means, what this macro means, is that if old school is defined, and do all of this stuff, include it in the source. So when I run it, it's going to work just like it did before. Right? It's asking me to do all the old school stuff. But if I comment out the # define, if old school is no longer defined, it's not going to do that block of code. That code's going to be left out when it's compiled. Notice it didn't ask me to do any old school numbers. So we've already seen # include as one of the preprocessor commands. # define is another one. It creates a variable. And # ifdef, actually I should call it a macro. It creates a macro called old school. And # ifdef is used to check to see if that macro is created. Or I could have just commented out, right? If I'd wanted to comment it out, I could have done a // and then a /*, right? But we already know how to do that, so I wanted to show you something else. All right, is anybody getting errors after all that stuff that I typed? May have not have gotten, all right. Onward and upward. That was a long page. Oh, really? It's forgotten what? Oh, yeah, that's because we're looking at set W. Okay, so the stream manipulators. Set W is one of the stream manipulators, which you get to by # include iomanip. Stream manipulators because you send a stream of data to cout, and you can change how they are processed by using things like setW. Well, there's another one too. Do you remember on my print statement I was able to specify how many decimal points to print? Pi equals %.3, like that. Say that I wanted 3 places after the decimal point. Well, we can do that with an IO manipulator as well. Let's put that above the old school stuff though, because it's new school. It's using the output stream. The one we want now is called set precision and fixed. We're going to use these two to force our output to a certain number of decimal points. So cout less than fixed semicolon, cout less than set precision parentheses. How many places do we want to display pi to? I don't know, only 2. So parentheses 2 in parentheses. And then let's do cout less than quote rounded pi is space end quote less than pi less than ENDL. And since I bragged about it a lot, let's make sure it works. All right, so rounded pi is 3.14. That did work. to me, I almost like this syntax better, but that's probably because that's what I learned to begin with, and that's how Java does it in Python and a lot of other things. I like being able to specify the number of decimal points by something like that, rather than having to do this. One thing to note is that we had to use setW every single time we wanted to format the integer that was following, or whatever it was. It doesn't have to be an integer. We only had to do this stuff once. If I print out a second number, like cout arrow arrow pi asterisk 2 to multiply it by 2, arrow arrow ENDL, that one's also going to be set to 2 places after the decimal point. Right? 6.28. So that's worth calling out in a comment because it's going to be a quiz question and an exam question. Set W has to be called each time before the data to be formatted. Fixed and set precision can just be set once, but then if you need to change the precision, you set it again. I don't know how to undo the precision once you set it, right? If you wanted just to go back to its old default behavior, there's probably a way to do it, but I don't know how. Now, where set precision and set width really shine is when you're printing tables. And to print tables, you're usually using a loop. We're not using any loops yet because we haven't gotten to that chapter. But we've done other programming languages. We know what a loop is, so let's go ahead and use a loop now. And if you haven't taken Java, this syntax is going to look a little bit weird, but not that weird. You Python folks probably remember seeing something like this. Don't type this. For I in range 1, 101, 3, something like that. Start at 1, go until, stop before it hits 101, and increase it by 3 each time. And so I would equal 1, 4, 7, 10, right? Something like that. Or if you said, I want you to go from 2 to 11, and I want you to skip 2 each time, it would print 2, 4, 6, 8, 10, and it would stop before it hit 11. That's what a for statement looks like in Python. Or at least one of them. I'll see, once I mention Python, I start trying to use Python comments. If you were going to do it in C, C++, Java, it looks more like this. For parentheses int I equals 2, semicolon, I less than 11, semicolon, I plus equals 2, close parentheses. And then cout, arrow, arrow, I, arrow, arrow, I times 2, arrow, arrow, I times 3, arrow, arrow, ENDL. That's not going to look real hot. The numbers are going to be all squeezed together. So just for now, let's just cout I. Get rid of everything else and just cout I followed by ENDL. All right, and you see it went 2, 4, 6, 8, 10. This for loop counted from 2, and it kept going as long as I was less than 11. Now, honestly, in these languages, people usually like to do this while I is less than or equal to 10. I just did the less than 11 because that matches exactly the way the Python for loop works. I'm going to delete the Python for loop, and we're just going to leave this one here now because that's the way to do it. All right, I want to get back to the point where it was printing out several more things, right? So C out, less than I, less than. How about a space, quote, space, quote, less than I, star 2. Less than, quote, space, quote, less than I, asterisk 3. Less than ENDL. And see, we printed out a table, and it doesn't look good. The numbers aren't lined up. We should use set width to make it look prettier. And instead of star 2, let's make it divide by 2.0 and divide by 3.0. And it's going to look even worse, or maybe not. Let's see what it looks like. Well, that's honestly not horrible, but that's because we'd already set the precision equal to 2. Miraculously, it all lined up because we set the precision to 2 before. If we cut this code and we moved it up above the rest of it, if I cut that for loop and I paste it up at the very top as the first thing of main, then it's not going to be nicely formatted. Right? Here it is. Here's my table. 2, 4, 6. I'm tired of it counting by 2s. I'm going to make my table count by 1 instead. So I'm going to modify my for loop to start with I is equal to 1. Keep going while I is less than 10. And instead of adding 2 each time, I just want to add 1 to each time. So make it I plus plus. All right. See, looks tacky. Hard to read. And yeah, we could try to fake it by using some tab characters. If we replace these with tabs, maybe it would make it look better. Maybe not. I'm not going to even bother. We know now that if we used set W and fixed and set precision, we can make that table look a lot better. One of the problems with the table is that sometimes, right, 0.5, it's 1 digit long after the decimal point, and sometimes it's 5 digits long after the decimal point. And there may even be other examples. Doesn't look like it. Looks like it's all either no decimal points, 1 decimal point, or 5. We'd probably like it so that they were all the same width and they all had the same precision. No, I'm not going to make that change right now. We're going to leave that alone. All right, let's go a little bit more. Oh, syntax errors, anybody? Nope. Well, we're done with the chapter. There's one more I/O manipulator called always print decimals for floating point values. Well, if you set a precision, it's always going to print the decimal anyways. So, don't think we need that. Calling fixed forces it to use decimal notation rather than scientific notation. Printing out a floating point number will sometimes flip to printing out an exponent notation. But if you call fixed, it forces it to be in scientific notation always. I mean, non-scientific notation, just pure normal decimal notation. All right, we are done with chapter 2. Excuse me, chapter 3. And although I said let's keep going, this would be a good point to have a break, even though we haven't been here a whole hour. I need one. All right, chapter 4. To that effect, the first exam, we will go over the first exam the week before we do it. The
So
third,
you said the 1st of July.
yes, yeah. Let's post an announcement to that effect. If you cannot be here on July 1, you can take the exam at the library. 2nd floor, Testing Resource Center. Testing Center, I think it's called. If that was impossible for you, if you were going to be out of country for a month, then you could take it using a proctoring service called ProctorU, where you pay somebody $25 and you have to have a camera on your laptop and they watch you take it, right? Which, if you can't get on campus to do it, if you're taking pure online courses, is how you have to do it. Making decisions. Seems strange to wait until chapter 4 to talk about if statements, but that's the way this book is set up. It seems absolutely insane to be talking about I/O manipulators before you've talked about if statements, but that's the way the book's set up. All right, relational operators. We know this stuff. We know what greater than means: less than, greater than, equal to, less than or equal to, equal, or not equal to. However, there is one subtlety I need to mention. Which is this. If you're checking, oh, by the way, your if statements have to have parentheses in them, unlike Python. So if you're used to doing if x less than 3, just get used to putting parentheses around it. If you have these statements, and you want to do the opposite of if x less than 3 is not if x greater than 3. That looks like the opposite, right? I changed the less than to the greater than. You have to worry about the boundary condition when it exactly equals 3. If x was 3, is 3 less than 3? No, 3 is not less than 3. So this would evaluate to false. We want the opposite to evaluate to true. That's what opposite means. So we wrote it like this incorrectly. Is 3 greater than 3? It's still false, right? Both of these are false. Whereas if you wanted opposites, one of them would need to evaluate to true. Greater than or equal is opposite of less than. So how about checking for equality? You can do it like this. X not equal, exclamation mark equal 3. That's the opposite. And then the opposite of greater than is going to be what? Less than equal. Yep. X less than or equal to 3. Someday that'll bite you if you don't remember it, because you'll miss the edge condition when it's exactly equal. Other than that, there's not a lot to say about less than and greater than, right? Because y'all know them. The one thing to pay attention to is the double equals. Let me show you something. X equals or int x equals, I don't know, any number. If parentheses x equals, excuse me, no double equals, single equal. If x equals 7, cout error quote, wow, comma, 7, \n, end quote, semicolon. Now, it should give me a warning when I do this, but it's probably not going to give me an error. Yeah, it said 1 succeeded. Okay, so when I run it, should it print wow? No, no way, because x is not equal to 7, it's equal to 3. It printed wow. You go, what the heck? Well, I'm really curious, so I'm going to print out what x is. So cout less than x is space end quote less than x less than endl, and then run it and tell me what x equals after those statements execute. X equals 7. This if statement erased the value of x and replaced it. And since it was a non-zero value, it decided it was true. If we change that to 0, then it's not going to print wow, but x is still going to be replaced. X is still going to be corrupted. It's going to be replaced by the value 0. So it didn't print wow, but x has been erased and replaced with 0. Not what we want. If we look at the error list, hopefully it shows a warning. It didn't even show a warning. How about that? We have no clue. And if that looks like something you would never do once you learn to not use a single equal inside an if statement, well, I just did it not that long ago, and I've been doing this for a long time. So you got to use double equals for your comparisons. A lot of languages give you a syntax error. Python and Java give you syntax errors if you use a single equal there. C++ and C do not. I can't even really explain a lot of times when you would want to take advantage of the fact that you can erase the value of a variable inside the if statement.
It gave me a warning for that.
Well, why am I not? I'm not seeing the same warnings that other people are. Okay, great. I'm glad to know that it gave you a warning. What did it say?
Well, I just fixed it, but that's all right. It's still up here. Like it didn't fix it.
Yeah. So it's a 4,000 level warning? Or even higher? What's that code?
So C628.
6282. All right. So anyways, yeah, you might get a warning saying that you are using an assignment operator rather than an equality operator. I hope so. I'm disappointed that I'm not. But I've seen other examples recently where my machine is not configured the same way as the students. Or maybe it's because, nope, I have no idea. The laptop users may have installed a newer version of Visual Studio. But it should be something that kicks out a warning, so I'm mystified why it did not. So the relational operators. What that does is it evaluates to either true or false. It returns a Boolean variable. So if I do this, cout less than 9 greater than 8, less than endl. I guess it doesn't like that syntax, so I'm going to put parentheses here to tell it that it's going to do that first. Remember, just like, please excuse my dear Aunt Sally, parentheses happen before everything else. And it printed out a 1 because 9 is greater than 8. What if we change that to less than? It's going to print out a 0. Underneath it all, a Boolean true is just a 1, and a Boolean false is just a 0. So we can store the result of a comparison in a Boolean variable. Let's declare a double called ptemp for patient temperature, and they're at 90 9.2 degrees. And now we're going to check to see if they have a fever. Now, honestly, people's temperatures are not always the exact average of 98.6, like you may have heard. Some people run cold, some people run hot. But let's do that. Let's say bool space fever equals P temp greater than 98.6, semicolon. And so let's see out, arrow, arrow, quote, fever, question mark, space, end quote, arrow, arrow, fever, arrow, arrow, ENDL. It should say yes, just because 99.2 is greater than 98.6. Well, it didn't say true, it said 1. Same thing. We could put an if statement here, right? If parentheses fever, hit enter, see out, arrow, arrow, patient has a fever, backslash n, end quote, semicolon. Patient has a fever. This is what's commonly called a flag. A Boolean variable can be called a flag if you store the result of a comparison in it and then use it later, right? We're kind of flagging it down to make it do something later. So why don't you just use this condition, embed this condition right here? Well, good question. But this calculation may be a very complex thing. Maybe not just one value greater than 98.6. Maybe it had to hit a sensor, read the sensor, compare it to a lookup table, and then decide whether that was true or false. So this might be a function call here. That may take considerably longer to execute, and you would not want to call that function every single time you wanted to check it. So by calculating the flag and then basing your decision on the flag, you might be able to speed up the execution if you're checking the value of that variable more than once. I guess we could put an else here. Else, cout less than, quote, no fever, backslash n, end quote, semicolon. Patient has a fever. Well, that didn't change. I'm going to change his temperature to 96.6 just to see it print the other message. Right, if statements are real obvious. Not expecting people to have any problem with the idea of what an if statement is and what an else is. The if statement triggers if its clause is true. The else statement, if there is one, triggers if the expression is false. Now, normally we do put it real expressions. Well, when I say normally, you more commonly see expressions, you know, if something is equal to something else, something is equal to something like this. If parentheses p temp is equal to 0, end parentheses, cout less than, quote, he's dead, comma, Jim, backslash n, end quote, semicolon. He has a temperature of 0. All right, now really he'd probably be room temperature, but whatever. Something I do need to show y'all is what if we made it look like this? Cout, arrow, arrow. I'm sorry for the sick humor, guys. Better call the coroner. Backslash n, end quote, semicolon. Notice that when I hit enter, it tabbed my cout over. Well, I want it lined up there. I bet somebody could tell me what I have done wrong here because I've made a definite mistake. This looks like good Python code. If you put a colon here, it would work perfectly if we were in Python. So is ptemp equal to 0? I've highlighted the line. No, ptemp is not equal to 0, so I'm not expecting to see these messages. Do I see them when I run it? It says better call the coroner. We're seeing one of those messages. We are seeing this message. We are not seeing this message, but we are seeing this message. And the reason why is we're not using curly braces. If you skip using the curly brace, only the first statement after the if is subordinate to it. The next one is not. That's why I tried to space it out like that. So it skipped printing that, and then it did print this, no matter what. If I wanted it to behave the way that I was trying to line it up, I'd have to use curly braces. Now it will not print that because the temperature is still not equal to 0. So use curly braces if the code block after the if or the for or the while is more than one statement long. You know, this is a code block even though it's one statement. But if I had to put multiple lines of code there, I'd have to use semicolons. Excuse me, curly braces, or it would not work. Rule of thumb, recommendation. Use curly braces always. On the other hand, if you think it's easier to read like that, then you can leave the curly braces off. But it's not a bad idea. It's not going to break the code if I'd gone back and I'd put curly braces in, right? It does make the code longer on the screen. And since I am at a limited screen real estate compared to y'all, I tend to leave them off if it's just one line of code. So why is it a good thing to put them there? Because it's easy to go in and modify. You can just zip right in, make a single change, and not have to go and retroactively add the curly braces because they're already there. That's one reason. Not sure if I can come up with another one right now. In general, though, you can never go wrong by using the curly braces. You can put too many curly braces in if you want. Int xyz equals 3, curly brace, int abc equals 4. If I go here and I try to print out abc, C out less than abc less than endl, that's going to be a syntax error. And if I go here and I try to print out xyz endl, that's also going to be a syntax error, whereas they would not be in Python. The reason why is because abc is defined within these curly braces, and so it only exists, its lifetime is from here to here. Since there's a closed curly brace, the variable disappears and is not accessible at that point. The same is true for xyz. If you feel like using curly braces in order to allow yourself to create some variables and then be guaranteed that they disappear at the end of it, that's okay. I didn't even put an if statement or a while or something. You can just block off chunks of code like that if you ever feel the need to, if you want to have some variables that you want, to disappear after they're done. I think I'm just going to delete that. So, a relational expression can be assigned to a variable. We've already done that. Result will equal 1 if it's true. It will equal 2 if it's false. And it kind of looks strange. Like, what if we were checking to see if x is equal to y? Maybe that looks strange to you. Result equals x equals y. You just have to remember that everything on the right-hand side of the equal sign happens first. This equal sign has the lowest priority of all, lowest precedence of all. Everything on the right-hand side happens first. And so it's just checking to see if x is equal to y. And if that's true, it stores a 1 in the result. And if it's not true, it stores a 0 in the result. The if statement. It's the decision statement. Bless you. Allows statements to be conditionally executed or skipped over. It models the way we think of things. If it's raining, grab an umbrella. If it's cold, take a coat. Is it cold outside? Yeah, wear a coat. This one doesn't have an else, so it's something or nothing. Is it cold outside? Yeah, wear a coat, wear a hat, and wear gloves. Now we'd better use a curly brace here before that block and after that block is done. So the general syntax, if, parentheses, logical expression, something that will return a true or false, or a 1 or a 0. We've already seen that 1 means true and 0 means false. What it actually is that if this is anything other than false or 0, it triggers. So if you put a variable in there and it's a non-zero value, like equal to 9,999, it will trigger this. And again, I would create a Boolean expression there, something less than something, something greater than something, or a flag. But that's enough to say about that. So the way it's evaluated, that expression is evaluated. If it's true, then the code block that's subordinate to it, that's inside the curly braces or the one statement after it, is executed. Average greater than 95, print. Congrats, that's a high score. So here's something that'll flat out break your code, and it's so easy to do. I may even do it up here when I'm typing in code. Be real careful where your semicolons are. If, parentheses, ptemp equals 9999 in parentheses semicolon. Tab, cout, quote, how is that possible? Or 9999 question mark, how is that possible? \n. Notice that when I typed the semicolon, it back tabbed it for me. That's a clue that something is going wrong, but let's say that I'm stubborn and I add the tab back in. It says 9999, how is that possible? Well, we know that the temperature is not 9999, so something broke. What broke is that we put a semicolon there. But we put a semicolon after every line. No, that's not true. You never put a semicolon on a line above a curly brace. Or you never put a semicolon after an if, or a for, or a while. But the curly brace method kind of works. What is this really doing? If you put a semicolon there, it's the same as typing this. Is P temperature equal to 9999? Well, yeah, okay, do nothing. And then print this no matter what. And I guarantee that somebody is going to do something like this. And it's not because you're dumb, it's because it's easy to do. While ptemp is less than 9, semicolon. They're going to type some code in like that. They're going to put a semicolon there, and it's either going to be, it's probably going to be an infinite loop. Your program will just stop there. I could prove that. Not that we've talked about while loops in this class. You probably have in other ones. While ptemp is greater than 9, subtract 1 from ptemp. Right? And so it should eventually exit that loop. But it's not going to exit that loop. Let's print a little message here. Cout reducing ptemp by 1 \n. First, I'm going to make sure it works correctly, if formatted correctly, because there's not much point in demonstrating if it's wrong if I can't get it to work in the first place, right? So we saw it reduced ptemp by a whole bunch of numbers. Heck, let's print ptemp out. Ptemp, arrow, arrow, quote, space, right, okay. So we're going to get to see ptemp count down as a result of the while statement, right? Went all the way down. How's about if I made my mistake and put the semicolon there? I'm not getting my hit any key to continue message. It's in an infinite loop. I have to just kill the app. The reason why is because here's what it really is doing. While ptemp is greater than 9, do nothing. Okay, nothing ever changes ptemp, so it's going to keep repeating that infinitely as long as this was true. If it was false, it doesn't go into the infinite loop, but if it's true, it never gets out of it because nothing ever changes ptemp. So if you put a semicolon there, that's bad. If you put a semicolon there, that's bad. Breaks the code. If you put a semicolon there, it doesn't go into the if statement at all. No, it goes into it no matter what, whether it's true or false. If you put a semicolon there, it can make an infinite loop. Now, I'm going to delete all that, but I'm going to put a comment to that effect. Never, ever, 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 ever put a semicolon on the same line as your if or your while or for. Okay, now technically I can think of a way you could do that. If parentheses ptemp equals 0 greater than cout, okay, \n. Yeah, I put a semicolon at the end of that statement, but you know what I mean. We don't normally do that. We do that, right? So, bad colon. If x equals 3 end parentheses, semicolon. Don't do it. It'll probably get you. It gets me occasionally. Because it's easy to type. So, better place your statement on a separate line after the expression, indented. Don't place a semicolon after the expression. Be careful testing your floats and doubles for equality. I think I talked about this. Did I talk about floating point errors and how you have to subtract the two values? Yeah. So, inside your if, a 0 is treated as a false. Any other value that you happen to stick in there, if it's non-zero, to be treated as a true. But usually we put logical expressions in there, something that it returns a true or false. Expanding the if statement. More than one line of code, put them in curly braces. Creates a block of code. Else. Two possible paths of execution. If hungry, eat. Else, don't eat. Right? If have money and hungry, go out to eat. Else, stay home. That kind of thing. Two possible paths of execution. If the expression is true, it does one block. Otherwise, it does the other block. If expression, do block 1. Else, do block 2. Yeah. So if the number modulus 2 equals 0, if that's the case, it's an even number. Else, it's an odd number. How would we express that in code? Int num equals 7, semicolon. If parentheses, num modulus 2 equals 0. Now, oddly enough, you can leave off the equal signs and it would work just as well, but that's specific to this language because it would either be a 0 or a non-zero value. Cout less than num less than quote space is even \n end quote semicolon. Else open brace, and here I'm using braces where I hadn't been earlier just by habit. Cout less than num less than quote is odd \n end quote and semicolon. All right, and in fact, 7 is odd. If I change that 7 to a 6, it's true. You could do the same kind of thing to see if something is evenly divisible by 10, right? If number modulus 10 equals 0, you know it's evenly divisible by 10. If number modulus 3 is equal to 0, you know it's evenly divisible by 3. I'm not sure why you'd care, but you could do that. You can chain them together. Folks who got out of Python have used elif, right? If something, blah, 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 elif, blah, 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 else. That was how you did it in Python. There is no elif in this language. Instead, it's else space if. So something like this. Int grade equals 86. I made an 86. So if parentheses grade greater than or equal to 90, end parentheses, cout or quote, grade is an A, backslash n, end quote, semicolon. Else if parentheses grade greater than or equal to 80, in parentheses, cout less than grade is a B, backslash n. I've always wondered why there's no E. Why does it go A, B, C, D, F? I should Google that. Else, now this is a really mean teacher who only allows A's or B's or F's. Cout, arrow, arrow, quote, grade is an F, backslash n. And we could chain as many of these as we needed to. I don't recall if this textbook calls it, but if you have a whole bunch of if, else, ifs, some people call it an if cascade. And I'll show you why in a minute. Let people finish typing before I go nuts. So what is it going to print? I don't even need to run it. Somebody just tell me what it's going to print. I bet it's obvious. Don't maybe call names. Yep, it's going to print a B. What if I do this? What if I change that to a 96? And I'm not being pedantic. This is actually going somewhere. If I change that to a 96, what's it going to print? It's going to print an A. Now what if I took out the word else here? What's it going to print? A followed by B, right? Because they're no longer mutually exclusive conditions, right? It's going to, grade is greater than 90, so it's going to print A. And then grade also happens to be greater than 80, so it's going to print B. Now some people will write, not because they're dumb, some people will write it like this. If grade is less than 90, and then they're going to use the and symbol, which in Python is the word and, but in this language is ampersand, ampersand. Not that we've learned that yet, but that means if the grade is less than 90 and the grade is greater than 80, then it's a B. That's a perfectly valid way of doing it, but it's better to use else if, because else if guarantees that it's mutually exclusive conditions. And if I had it coded like this, but then the grade barrier changed, like your prof got easy on you and decided that 88 was an A, then you'd have to change it in both places, and it's better just to change the boundary at one place. So let me undo all those changes. Was there somewhere else I was going to go with that? Oh yeah, if cascade. I don't even think I'm going to type it in the real code. If, and forgive me for doing it in Python so that the syntax is easier. If grade greater than or equal to 90, colon, now I'm going to leave that off. Then print A, else, okay, I'm going to go ahead and make it look exactly like our language, except I'm leaving off the parentheses. Else, if grade greater than or equal to 80, print B, else, if grade greater than or equal to 80, print B, else, if grade greater than or equal to 80, print B, else, if grade greater than or equal to 80, print B, else, if grade greater than or equal to 80, print B, else, if grade greater than or equal to 80, print B, else, if grade greater than or equal to 80, print B, else, if grade greater than or equal to 80, print B, else, if grade greater than or equal to 80, print B, else, if grade greater than or equal to 80, print B, else, if grade greater than or equal to 80, print B, else, if grade greater than or equal to 80, print B, else, if grade greater than or equal to 80, print B, else, if grade greater than or equal to 80, print B, else, if grade greater than or equal to 80, print B, else, if grade greater than or equal to 80, print B, else, if grade greater than or equal to 80, print B, else, if grade greater than or equal to if grade greater than equal to 70, print C. Now there's kind of a problem with the way we've set this up, is how would we know when to print an F? I guess we would just do it right here inside this if statement right here. I guess I could throw in one final else to print an F. Alrighty, that's an if cascade. A cascade is a series of streams and waterfall, you know, like that. That's what a cascade is. And we can kind of see that syntax building up, right? If, and then we have one tab, and then we have two tabs, and then we have three tabs. There's really almost never any reason to write it like that if you can just use else if and take away the curly braces. So if I copied all this, pasted it, I really hope y'all aren't typing this, and made this else if, and then made this else if, and then fixed my tabs, right? That's how you oughta should do it. That is correct. The other one is technically correct as well. But if you have the option of doing it like this, where it looks clean and neat, as opposed to a whole bunch of nested if-else's, I would do it. I would do an if cascade like that. When you flowchart it, though, it winds up looking like this. Nested if statements. Oddly, that's just what we were talking about. You can put an if statement inside another if statement, just like you can put a loop in a loop, or you can put a loop inside an if, or an if inside a loop. Nested if statements can be used to test more than one condition. Like this. Let's declare a variable called hunger and a variable called money. Int hunger equals, I'm pretty hungry, 98. Think you're playing The Sims or something and your little hunger meter is going up. Int money equals 32. We have $32. If, parentheses, hunger greater than 10, or just make it greater than 0, in parentheses, semicolon. If money, if parentheses, money greater than 0, in parentheses, curly brace, see out, okay, let's go out to eat, backslash in quote, semicolon. The way it's set up is that this message is only going to be printed if both this if statement and this if statement are true. So if you've heard the and logic, this is setting up an and condition. Hunger has to be true and money has to be true. They both have to be above 0 before this happens. So once you learn the logical operators, you can replace some nested ifs with a statement that looks like this. And even though it's not in the book yet, I'm going to go ahead and tell you that shift 7 ampersand ampersand is equal to the word and. And the vertical bar shift above the shift of backslash bar is equal to the word or. And so I'm going to rewrite this now. If parentheses, hunger greater than 0, and then the shift 7 ampersand ampersand, money greater than 0, close parentheses, see out, less than, okay, let's go out to eat. You can see it's a more concise way of expressing it. You don't have to use nested ifs if all you're doing is chaining conditions together with AND logic. Am I hungry and I got money? Go out to eat. Well, we can express that in a single if statement. And sure, you know, one reason that this is longer is because I use curly braces here and I didn't use curly braces there, but it's still easier, right? Easier to read if you word it like this rather than the other one. Now, strictly speaking, there's nothing wrong with doing it the first way. They're pretty much exactly equivalent. And there may be times when you want to put in the nested ifs because you may have some logic that's more complicated than a single AND logic there. AND just means that both sides have to be true. Because if hunger was not greater than 0, it would not go in here. Just like up here, if hunger is not greater than 0, it's not going to go into that code block. So AND is a binary operator where both operands are evaluated to see if they're true or false. And they both must be true before the expression is triggered as true. That's the way we think about it. If I'm tired and it's after 7, go to bed, right? Both things have to be true. So here's our logic. Are we employed? Yes. Are we a recent grad? Yes. If we're a recent graduate and we're employed, we print display. You qualify for the special interest rate. Otherwise, we display, sorry, you must have graduated from college in the past 2 years to qualify. I guess that's what recent grad means, is within the past 2 years. Else, print, you must be employed to qualify. Now, here's an example of when it had to be implemented as nested ifs, because they have 3 choices. This logic here really only gives you one thing or the other. We could stick an else in, right? But we don't have the ability to throw in 3 if statements unless we did it, 3 outcomes unless we did it as nested ifs. Hope that kind of makes sense, right? Because if these 2 things were linked together with a single AND statement, if this said if employed equals Y and recent grad equals Y, then print you qualify for the interest rate, there'd only be 2 options. One is to hit that, and the other is to not. So here we have the option of 2 different error messages. Now, if I was writing it, I probably would just have done if employed equals Y and recent grad equals Y, then display, yay, you get the interest rate. Else display, sorry, you must be employed and be a recent grad, right? Tell it both things. You don't need 2 error messages when one can handle both. So if employed equals Y, if recent grad equals Y, this is nested, then print you qualify for the special rate. And that flowchart had some else's, so we could expand the code to have some else's. Else, if we're not a recent grad, print sorry, you must have graduated within the past 2 years. And this else would be sorry, you must be employed. The if-else-if statement, we just demonstrated that with our grader. You know, you made an A or a B or an F. Tests a series of conditions until one is found to be true. Once it finds one that's found to be true, it dumps out of the entire logical construct. And what does that mean? It means that once we got here, if this one is true, it doesn't keep checking after that, right? The rest of the if-else-if cascade, the rest of the chain is all skipped. So these are mutually exclusive. It's only going to be that one, or that one, or that one. It doesn't matter how many else-ifs I have. I could have 7 million else-ifs in a row. Once it finds one that's true, all the rest of them are ignored. So, often simpler than using nested if-else statements. Just like I showed you that cascade, it kind of looked a little bit more complicated. Model's thought process is like, if it is raining, take an umbrella. Else, if it is windy, take a hat. Else, take sunglasses. What if I want all 3 though? I don't know. when you have a series of if-else ifs, it's always a good idea to put a final else in there to catch invalid states, unexpected states. You may think that you've handled absolutely everything with your if-else if statements. But if you get into a state where something is not true, none of these are true, and it does nothing, then you may not be expecting your code to do that. I'll give you an example. What if our code said this? Cout error, quote, type 1, 2, or 3, and press enter, \n. I forget if I have a variable named x. Well, I'll create a new one. Int choice, semicolon, cin less greater than choice. Now I'm going to cook up some if statements. If parentheses choice equals 1, then cout greater than quote 1 \n, end quote, semicolon. Else if parentheses choice equals 2, in parentheses, cout less than quote 2 \n, end quote, semicolon. You can see where this is going. Else if parentheses choice equals 3, in parentheses, cout less than quote 3 \n, end quote. Looks good. Perfect. They're going to get to type in 1, 2, or 3, and depending upon what they got, what they enter, we're going to print something. You probably already see where I'm going with this. Type in a number, 1, 2, or 3. Okay, I'm going to type in 3. 3. It worked. It printed out the word 3. Run it again. Type in a 2. It printed out 2. Run it again. Type in a 1. I'm testing all of my inputs. 1. It printed out the word 1. Everything is awesome. And then I run it one more time, and let's say I slip, and I accidentally type 12. And it doesn't do anything. Usually you want to know why it didn't do anything. Now, we could have worded it a little bit differently, and we could have just done this, right? Don't do this. If the choice is a 1, print out 1, else if the choice is a 2, print out 2, otherwise print 3. But that's not accurate. Right? If I type in a 12, I don't want it to print 3, which it did. The correct thing to do is to put a final terminating else to say invalid choice, \n. You do that if you have a series of if-else ifs, just to rule out the possibility or to alert yourself as the programmer, if not the user, that a choice was made that caused nothing to happen. Now when I type in 12, it's going to print invalid choice, which is much better than just not doing anything. Type in 12 and it says invalid choice. So pretty much always use a final else if you have an if-else structure, or if-else if structure. To alert that an invalid value an invalid state, an invalid value was entered, something like that. That no code was, that the choice that was entered executed no code. I'm trying to think of a good way to say that. Let's look at the, if it says anything. Okay, the trailing else clause is optional but can catch errors. Okay, I guess that's a good way to say it. To alert that an invalid state, parentheses, error, might exist. The homework assignment over the concept of if statements is going to be this. We're going to write a program that calculates the weight of a certain size sphere based on its material. Here's how it might look when it runs. We will calculate the weight of a sphere based on its size and material. Choose the material of the sphere, ice, aluminum, or gold. They type in gold. And choose the size of the sphere, marble, golf ball, or baseball. And then it does some calculations. The density of the object is 1203 because gold happens to weigh 1,200 pounds per cubic foot. Whenever you think of it, one of those adventure games where your player finds a chest of gold and then drags it away, well, if that chest contains 2 cubic feet, that thing weighs more than a ton. They're not going to be dragging that chest away. The radius of the object is that, based on the size. The volume of the object is that, and then the weight of the object is that. So they said they wanted a baseball made out of gold, and it turned out to weigh 72 pounds. It's pretty heavy. Gold is a heavy substance. So the requirements. The program will prompt the user with a menu of sizes, just like we saw here, ... But we're going to support more than 3 sizes. We're going to support marbles, golf balls, and baseballs, and basketballs, and beach balls, and exercise balls. Prompt the user with a menu of materials. For example, ice, aluminum, gold, iron, cedar, soil, dry. I don't know why I said dry when there's no soil wet option. Paper, and osmium. Osmium has the honor of being the heaviest naturally occurring element. It's not the largest on the periodic table, but it is the densest. It's denser than uranium even. So once we know the size and once we know the material, we can determine the density, we can calculate the volume using an equation, and we can calculate the weight. I guess if I was going to be technical, I should call it mass. Using that formula and display the results. Now, why don't we just give this a little bit of a start? And then we can finish this homework up at home. So I think I'm going to scroll all the way up to the very top of main to be adding this code to kind of, rather than at the bottom. But here's what I wanted to say. I wanted to say we will calculate the weight of a sphere based on its size and material. Choose the material of the sphere. Ice or aluminum, we should list a whole bunch of things. And then choose the size of the sphere. Marble or golf ball, we should list a whole bunch of things. And then we should do the calculations. Let's do that. I'm going to come up here to the very top of main. We're going to need some variables. We're going to need to know the material they chose, int material. We're going to need to know which size they chose, so int material and size. Also, we're going to need to calculate the density, so double space density, comma volume, comma radius, comma weight or mass. I'm just thinking ahead. I'm pretty much sure, since I've written this program before, that these things are going to be what the user enters, and these are going to be the values that we calculate based on that.
Why would you not consider all of them a double?
Very good question. But since it's going to be a multiple choice thing where they pick 1 for this, 2 for that, and 3 the other, I just feel better about using ints for that since they're discrete choices. No other reason than that. They could have all been doubles. You're exactly right. So, cout less than sphere calculator. It's not what the assignment told me to do, but we're just doing this real fast. Okay. C out less than. We need to list the materials. One equals ice. 2 equals 1 equals ice \n. 2 equals aluminum. \n. C out less than. Your sphere is what material? Question mark. Space greater than. End quote. Semicolon. Now we're going to read their choice into the material variable. So CIN greater than. Thank heavens we're not using scanf. Material. Obviously, we're going to have to, when we do our homework, add the other materials there, right? It's not just going to be ice and aluminum. And now let's print our sizes. I'm going to have to look back at the example to remember the sizes. Marble or golf ball. So C out less than quote 1 equals marble \n. 2 equals golf ball \n. And how you present the menu is up to you. You can make it as pretty as you like. End quote, semicolon. C out less than quote. What size is your sphere? Question mark, space greater than. End quote, semicolon. And let's let them type that in as well. CIN greater than size. Now we need some if statements. Because if they chose 1, then that's a density of something. If they chose 2, that's a density of something else. So, if parentheses material equals 1 in parentheses, then density equals, and I'm going to have to look at the table. There's no way I have that memorized. Although I do have gold memorized for some reason. Let's look this up. Ice has a density of 55. 55 pounds per cubic foot. So density is equal to 55. Else, not else, else, if parentheses material equals 2, in parentheses, this is aluminum. About the lightest metal. There may be lighter ones. Lithium is lighter, but it's more unstable than aluminum. Density equals sodium's lighter too, but it burns when exposed to pure water if not in salt form. Aluminum is 168. And then a final trailing else to tell them that they've made an invalid size. Else, curly brace, C out, less than, quote, invalid material choice, \n, end quote, semicolon. C out, defaulting density to 1, \n, end quote, semicolon. And then let's set the density equal to 1. We could set it to 0, right? And then their answer would always be 0, whatever. We're giving it some backup choice so that if they goof up and pick something not on the menu, at least the rest of the program runs without crashing. We could be nice and tell them the units, right? Defaulting density to 1 foot per cubic, 1 pound per cubic foot. Why don't we test it just to make sure we don't have any syntax errors this far, rather than type in 2 more pages of code? Your sphere is what material? First, I'm going to get it wrong. 3. What size is your sphere? 2. All right, and then it did a bunch of stuff, right? Maybe I could put a system pause there if I was on Windows. The Mac users wouldn't have this option. System, parentheses, quote, pause, just to break things up there so that when I test it, there, right, pressing the key to continue. One could argue that this if statement should immediately follow where they entered it, right? Might not be a bad, because otherwise they're waiting until we ask the size of the sphere to tell them that they chose an invalid material. Yeah, why don't we take this stuff, cut it, and paste it above the golf ball marble statement? So I'm going to take that entire if-else-if structure all the way down from here to there and cut it and paste it above the marble golf ball statement. Cut, paste underneath that CIN material. Then I'm going to pause, make sure everybody's doing okay. Why did I do that? So that if I enter a wrong material, it tells me immediately. It doesn't wait until after I've entered the size, right? Your sphere is what material? 10. Invalid material. Defaulting density to 1. Okay. You know, I could make it say defaulting to ice and then set the density to 55. Why don't we do that? That makes a little bit more sense. Ice. Density equals 55, right? There are more elegant ways of setting this up than just big series of if, else, ifs. We could set up tables with arrays. We could use a switch case statement if you've ever learned of a switch statement. Okay, I said I was going to pause. Why don't we pause? Make sure. Well, let's handle the second question now, right? They've entered the size. Golf ball, marble, what size is your sphere? We need to set the radius appropriately. Now, is my table annoyingly written so that the sizes are written in diameters rather than... That's annoying. What do I mean by that? Because we need the radius to calculate it. I guess we'll handle that down in our math. We probably ought to have a variable called diameter and then convert it to feet. Excuse me, convert it to radius by dividing it by 2. Or we could go in and we could modify all these values, but I'm not going to change it in homework assignment. Instead, I'm going to come up here and we're going to add another variable here. Double density, volume, radius, weight. We need one for diameter. Now, you could get away without it, right? We could just modify our expression to use diameter divided by 2 rather than radius. And hopefully y'all remember enough geometry to know what I mean, right? Diameter is from one edge of the circle to the other. Radius is from the edge of the circle to the middle. And that distance there to the middle is what all mass formulas like volumes and surface areas and circumferences use. Alrighty, so after CIN greater than size, if parentheses, size equals 1, it's a marble. Heck, I could even put that as a comment. You know what? I should have been doing that up here. My other if statement. If material equals 1, comment ice. Else if material equals 2, comment aluminum. Else error. Now back down here. If size is equal to 1, it's a marble, and so its diameter equals 0.05. And I don't know why I put curly braces here where I wasn't using them up above, so I'm going to get rid of that. How did I misspell diameter? It's not diameter. It's diameter. Hopefully you didn't make the same typo. Else, if parentheses size equals 2, then it is a golf ball with a diameter of 0.14. Diameter equals 0.14, semicolon. And we better put our error case. Else, comment, error, less than. Same kind of deal. We're going to tell them invalid choice, defaulting to marble or golf ball or something like that. So cout less than, quote, invalid choice, defaulting to marble, \n, end quote, semicolon. And I put my, I think I said less than, or maybe I just said arrow, but I put those going the wrong way. Definitely should be less than. And then we're going to set the diameter equal to the size of the marble. Now I sure do see a lot of red underlinings for cout. Oh, I see why. If you ever see all of your CINs and COUTs suddenly light up with errors, it is because you have too many closing curly braces. Now that's not intuitive, right? You wouldn't think, oh, I had too many closing curly braces as soon as you see all the COUTs fail. Just bitter experience has told me that's the case, and I did have too many closing curly braces. Not quite sure why. Haven't figured that out. Okay, now we have the diameter and density. Let's get the radius. Radius equals diameter divided by 2. And so now we can calculate volume and weight based on the formulas in the instructions. I could leave that to y'all, or we could do it now. Why don't we do it now? Volume based on radius is not 2 pi r. It's not pi r squared because that's surface area. It would be 4/3 pi r cubed. So volume equals, and by the way, I'm going to make a deliberate mistake, just know in advance, 4 divided by 3 times pi, or excuse me, m underscore pi, because that's how the constant is defined in the include file, times POW parentheses radius comma 3 pi r cubed. Now based on what we've said about integer division, what is wrong with that expression? It would work in Python, by the way, because Python doesn't do integer division by default. What is integer division? Integer division is when you divide an integer by an integer. What does that give you as a result? This is important stuff, so I'm going to have to jump up and down and make sure y'all remember it. An integer divided by an integer gives you an integer. Meaning what? 4 divided by 3 is what? Not 1.333. It rounds down to what? So our expression is now completely wrong. Volume is equal to 1 times pi times radius. You have to force it to do floating point math. There's lots of ways you could force it. One is you could just convert one of these to a float like that. That would fix it. But why do that if we could just type that, right? 4.0 divided by 3.0. This one would have been a somewhat subtle error because 4,3 dividing, rounding down to 1 isn't that obvious unless you know what answers you're looking for. But if it was 1 over 2, that rounds down to 0, and so your answer would always be 0. That one leaps out, but this one would not leap out so much. Okay, so that's the volume. That makes sense, guys? Please remember. If you use division, integer on one side, integer on the other one, it rounds down to an integer. Hey, if you want to get computer sciencey, instead of saying round down, say truncate. It truncates to an integer. All right, now let's calculate the mass, which I happen to remember the equation, having written the assignment. Weight equals volume asterisk star density. And then let's just see out the weight, but I want you to modify your homework to actually do all of this print statements, not just weight is space end quote less than weight less than pounds over foot 3 backslash n end quote semicolon. Now I'm going to run it and choose to make an aluminum golf ball, and I don't know exactly if the answer is going to be right because I don't have those things memorized, but at least we'll get some number. Your sphere is what material? It's an aluminum golf ball, and it weighs about 1/4 pound. I can believe that. It's an ice marble. Ice marble. Pretty light. Yeah. Even if you have marble-sized hail, it's pretty light. I believe it. By the way, the density of water in pounds per square feet is 8.3. Anything that has a density of less than 8.3 floats. Anything that has a density of greater than 8.3453 sinks. So, no, that's a gallon. So it's 62 pounds. Anything that has a density of greater than 62 pounds will sink. If it has a density of exactly 62 pounds or less, it will float. And if it's even lighter than that, if it's lighter than the density of air, you know, it'll float in the sky. So if we look at our materials, some of these things would float and some of them would not. 62 pounds being the limit. Ice floats because it's less than 62 pounds per foot. Aluminum does not. Neither does gold. Neither does iron. Wood does float. Soil does not, although if you take soil and you throw it on water, yeah, some of it will float because of surface tension. Paper, yep, paper is less, so paper floats, and osmium does not. Don't know why I went off on that tangent, except I remember giving giving a class a homework assignment where you had to say whether the material would sink in water, float on the water, or rise into the air. Now in this case, it doesn't make much sense to ask if it's going to rise into the air because we don't have any lighter than air gases listed, right? Like helium or hydrogen or anything. Okay. This is a functional working version to base your homework on, right? Everything from here down to here would work as homework. I'm going to flag that with another # define, # if-def. So # define space homework. And then # if-def homework. And I'm going to go and put the end if way down right after that pause statement, maybe, or before it, after it. Why not after it? # end if. So you saw the change I made? After my first system pause, I put the # end if. Before my code where I declared the material and the size and the diameter and stuff, I did # define homework and if-def homework. If I comment out the homework part, now it's just going to run the other part of the code that we did. Right? No longer asking me for. We could cordon that off inside something that was # define notes or something like that, right? You know at this point how to do it. You would do # define notes, and then you would do # if-def notes, and you would put all of this in there. I think that's overkill. I don't see why we need to do that, but I'm happy with the way this looks now. I'm kind of showing this to you because not very many languages, in fact, this and C, straight C, are about the only languages I know of that support preprocessor macros. They're one of the things that make the language unique, and so I'd like for y'all to get used to the idea. All right, we're at that awkward stage where it's too early to leave, but I don't want to talk about anything else. Is it working for everybody? Anybody getting syntax errors that you wish we would? Well, I know something we could do. It's a fun trick. Why don't we take attendance again?
So you have a slot already made to upload today's stuff?
No, because you'll leave as soon as I do. All right, let me make it.